Welcome back, Algebra kids. Oh, I love this stuff. I'm telling you, this is the fun stuff. 11.7, adding and subtracting radical expressions. Do you remember we talked about radical yesterday? What it means to be radical? Right, it was the square root. Well, I just want to throw something out there because we're going to talk about like radicals. Okay, so we have talked in the past about like terms, haven't we? We've talked about how you can add a 3x and a 4x and get a 7x, but you cannot add a 3x squared and a 4x. No, I didn't mean to put an x. I meant to say, no, you can't put those together, can you? Because they're not like terms. You can't put an x squared with an x. You've got to have like terms. Well, guess what? When you're adding and subtracting radicals, you have to have like radicals. So that means in order to add or subtract anything with a square root in it, what's under the square root has to be exactly the same. So let's take a look at this definition. Okay, so those are officially square root expressions with the same radicand. Okay, so when we look at example 1, add or subtract, are the radicals like? Can we subtract? The answer is yes. We got a square root of 3 and a square root of 3. They are the same radicals. So therefore, all you do is you leave that the same and you subtract what's in the front. So it'd be 9 minus 4 is 5, and the radical stays the same. It's kind of exactly like we had up here. 3x plus 4x was 7x. I didn't change the x. Same thing with the radical. Okay? So when we look over here, 6 root x plus 8 root y. Are the radicals like? Are they like radicals? No, they're not. Square root of x, square root of y, those are not the same. So guess what? You can't do anything with this. If it's multiplied, we talked yesterday about how to multiply. We could do that. Or maybe we didn't quite talk. No, I don't think we quite got into it yesterday. We'll get into that more later. How about that? Square root of m minus 7 square root of m. Are they like radicals? Look pretty much the same to me. My only question is, what's here? That's right, it's a 1. So 1 minus 7 is negative 6, and the radical stays the same. Okay, there's clear-cut rules for when you're adding and subtracting versus multiplying and dividing, and they're different. So this is when we're adding and subtracting. Let's look over here. Do you see any like radicals? Hopefully you said yes, and you recognize that these are your like radicals. This is not, because even though it has the y, it doesn't have the x, and it has to be exactly the same. All right, so I can combine these. I've got a 2 plus a 9, so I've got 11 square root of xy, and then this just stands by itself. You cannot put that with the other one. Okay, so those are really basic things about adding and subtracting radicals. Now we're going to add a piece from yesterday on. So we're going to add and subtract radicals, and we're going to get into the actual variables here with the y's in a minute. Here we're going to start with numbers because it works the same whether you have numbers or variables. What's underneath the radical has to be the same to put them together. Okay, so right now we can't put those together. 45 and 20, But yesterday we learned how to simplify them. So we need to simplify them down before we can actually say yes or no. So this is where you're going to break them down. And do you remember those numbers that we circled? Let's see if we can remember them. 1. What's the next one? 4, 9, 16, 25, 36, 49, 64, 81, 100. Okay, and how did I get those? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, and 10 squared. Do you see any of those when we look at 45? Any of these a factor of 45? You betcha, the 9. So we can break that down to square root of 9 times what? 9 times what gives you 45? 5. Remember, only one of these has to be this. And the reason is because square root of 9 cancels and it's 3. The square root is gone now. I don't put it down here. The only one that couldn't simplify is that, so I leave the square root of 5 there. Okay, because we have two different terms here, I'm going to use blue pen for this so we don't get these mixed up. So now I'm going to look at this. 40. Can you see any factors here of, not 40, 20? That's right, the 4 is, isn't it? So square root of 4, and 4 times what? Gives you 20. 5. Great. Square root of 4 is 2. Square root of 5. This subtraction sign is still there. All right, so now can we simplify? Do we have like radicands? Yes. So now we can subtract 3 minus 2 is 1, and square root of 5 stays the same. I have 3 square roots of 5 minus 2 square roots of 5. I have 1 square root of 5. Of course, you can just write that as square root of 5e without the 1, 2. Okay? Let's take a look at this. I would challenge you to turn off the recording until you've had a chance to try it, and then bring it back on. All right, so we have in this one, the difference between this and this was there's a number now in front of it other than 1. It was just a 1. Now it's a 9. No problem. The 9 just stays out front. So I'm just going to put the 9 there. Okay, and then this still breaks down. It's all one thing. Okay, so 75. Do you see anything in here that 75 divides by? Or that divides into 75? Yes, the 25 does. I think quarters. How many quarters? 3. Square root of 25 is 5. Still have my 9, and I have my root 3. So the way this, first of all, make sure you don't lose the 9. That's out front. These are, again, all multiplied. So when I'm done here, I actually have 45 root 3 for that first term. Let's go to the other side. Okay, again, we got the 2, and then we're going to break this down. 50. What do you see? That's right, you got a 25 and a 2. 25 times 2 is 50. So the 2 gets carried down times 5 times square root of 2. That's why we did it. If something isn't a perfect square here, I don't want 5 and 10. Okay, class? 5 and 10, square root of 5 times square root of 10 gives me, guess what? Square root of 5 and square root of 10. It doesn't break down anymore, and we're trying to simplify here. So if one of the two doesn't break down to a whole number, then you've picked the wrong set. 2 times 5 is 10, square root of 2. Okay. And don't forget our plus sign. So now we take a look. Are the radicands like? Are they, I mean, not rad, are these like radicals? Absolutely not. Square root of 3, square root of 2 are not the same. So that is as far as we can go with that one. We're done. All right. Now this one has how many terms? That's right, it's got 3 terms. Okay, so let's take a look at that. And we've got a number and a variable inside there. So I'm going to break it down 3 times here. So the 75, can you think of 2 numbers that can be broken into? Sure, 25 and 3, same as it was over here. And the y, if it was a 2 here, right, the 2 and the square root would cancel, but there's not. So it's just a good old y there. Square root of 25 is 5. And now you can leave these together. These will not break down. So you can put them back together there. Either one will break down. All right, let's look at the next one. 2 y. I'll put that in there. I can see that's going to go nowhere. Now the 27. Do you see anything for the 27? Oh, sure enough, the 9. Okay, so we have a 9 and a 3. So we have 2 times 3 times that. So the ones on the outside of the radical I can multiply, and the ones on the inside can be also multiplied. Bring down the subtraction. Bring down plus. Go back to my red. All right, so square root of something, square root of something, square root of y. All right, 48. Let's look over here. Yeah, I think 3, let's see, 16. Yep, 3 and 16. That's a tougher one, some may not recognize. Play around a little bit with your calculator until you get more comfortable with these. Square root of 16 is 4. And I can again put these back together because they don't reduce down anymore. And I'll just rewrite it right here. Do we have any like radicals? Square root of 3y, square root of 3y, square root of 3y. I can combine all of them by adding these. So I have 5 minus 6 plus 4. Looks like we got 3 left, don't we? And the radical is exactly the same. All right, our last problem today. Find the perimeter of the triangle, give the answer as a radical expression in simplest form. Okay, so perimeter, we're just adding them. So we have 3 root 20 plus 13 root 5 plus 10. So how many terms do we have there? That's right, we have 3. Let's take a look at this. We got the 3, and does the 20 break down? Yep, 4. 4 and 5 give us 20. So I'm left with 3 times 2 times square root of 5. Square root of 5 doesn't reduce. There's nothing that I can break down into, so I'm going to just carry that down. Bring down my plus. Bring down my plus. Now, what can I put together there? Well, let's finish this up. We didn't finish that. That's 6 root 5 plus 13 root 5. Switch my colors back here to plus 10. These two have like radicals, so I can put those two together, but I can't put it together with the 10. So I'm going to have 19 root 5 plus 10. Parentheses around it, millimeters, all together. All right, so hope that clears things up a little bit. Give it a shot, and I'll try your homework right away and see how you do. All right, take care. Have a good day. God bless.